I published the video in YouTube, and I also send a link on Butela. So under every chapter, let's say this is chapter 5. So I'm gonna write the chapter 5. If there's a slide for chapter 5, I put that slide there, and also there's a recorded video. But the link will be leading you to YouTube. So it's very important for you guys to watch the videos. First of all, you see, our projector is not the best projector, but on the screen recording, it's crystal clear. So whatever that you'll be watching on YouTube, it's not as hazy as my projector. You understand? Because our institution decided not to replace the broken or stolen projectors. You understand? I don't know. Maybe they think, Corey, we are now an FET of some sort, I don't know. But they have to do this thing so that our life can be easy. Not all of us teach with a book. I don't teach with a book. I can't. I just can't. I've studied my entire life with a book. I cannot teach with it anymore. So, and my method of preparing for class is 10 times longer. I need more than 2 days to prepare for a single class because I do screenshots for each and every statement that is there, and therefore it takes forever. So I think this is the first section. It reads as follows. In industry, remember I will introduce this chapter. I'm still waiting for this. Okay? Theoretically using slides. Now I'm going direct into calculations because that's where the money is. I'm starting to calculate it so that I can know what to take in my exam. Remember, we don't go into deeper. So, in industry, business, healthcare, education, and government, the mass of data that has been collected is voluminous. Ne? Even one item such as the number of daily billing errors of a large organization can represent such a mass of data that it can be more confusing than helpful. Consider the data in table 5.1. Let's look at 5.1. Okay, this is just to show you that I was practicing. I overly prepare for all my lessons. I hate freestyling, in fact. So this is the data that we have, as you can see. We have zeros 1, 2, 3, 4 until 5. So it's just the data. You don't know what it means and stuff like that as yet. So as you can see that the data, when you look at it, you say, I see ones and zeros, and you can't do anything basically with it. However, clearly these data in this form are difficult to use and are not effective in describing their characteristics. Some means of summarizing the data are needed to show what value or values the data tend to cluster about and how the data are dispersed or spread out. Two techniques that are available to accomplish this summarization of data is graphical and analytical. The graphical technique is a plot of picture of a frequency distribution, which is a summarization of how the data points observations occur within each subdivision of observed values or groups. All right. So now what we intend to do here is when you look at the data, when you look at the data, you can see that we have 0. We have 0 here. We have 1. If you look there, we have 2. We have 3. We have 4. We have 5. Ultimately, you can see that, okay, this data, we can nicely stick it on the side as 0, 1, 2, 3, 4, 5. Ne? So, that part, we know that we actually this is for non-conforming parts. Ne? 0, 1, 2, 3, 4, and 5. Okay? So now, using a tally method, ne? I want to see where they suggest that you must use a tally. Okay. I want you to use a tally method. Use a tally method to identify all your zeros, all your ones, your twos, your threes, your fours, your five. Ne? So there are two approaches to do that. It's either you will do it like this, or you will do it horizontally. Ne? You can start from top to going bottom, but don't do it randomly. Do not, whenever you are doing the frequencies, do not do it randomly. You're going to have a serious problem if you're doing it randomly. You won't be able to pick up all the values that are there. So now, if we look at the zeros, we have, let's say we start from the bottom here with 1, 2, 3, 4, 5. Then we come this side. We have 6. Come there. Nothing here. 7, 8, 9, 10. 11, 12, 13, 14, and 15. Ne? So how do you tally that? You see that? This is how we do our tallies. Ne? The first thing first we do is the tally. Ne? Okay? Then that is your 15. Your frequency is 15. Like this. Okay? Then we are looking now for the ones. Same thing. Because I have the luxury to change my pen, I will change the pen so that you can be able to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So the tally is 1, 2, 3, 4, that 1, 2, 3, 4, that 1, 2, 3, 4, 1, 2, 3, 4. And then you have your 20, right? Then you carry on. You carry on just like that. We are now doing for 2. 1, 2, then 3, 4, 5, 6, 7, 8. So this one is 8. Its tile is going to look like this. 1, 2, 3, 4, 5. 1, 2, 3. Then that's your 8. My pen's not visible. That's your 8. Okay? Then for 3, 1, 2, 3, 4, 5. For 3 you have 1, 2, 3, 4, and 5. That's your 5, right? Then for your 4, you have 1, 2. For your 4, you have 2, 3. 1, 2, 3. 3. For your 5, as you can see that 5 is the only guy there. 5. That's your 1. So this is how you are doing you find the frequencies. And then this is for the ungrouped data. Ne? This is for the ungrouped data. Okay. So another type of graphical. Okay, I want to read here. Frequency distribution are presented in a graphical form when greater visual clarity is desired. Okay. So if you want to see in a graphical manner, you use the frequency distribution. All right. So if I were to ask you when do you use frequency distribution? It's when greater visual clarity is desired. Okay? Because we are using distribution. Okay, I can see that some of the stuff that I'm doing are not visible. So yeah. And then a histogram consists of a set of rectangles that represent the frequency in each category. So these are your histograms basically. These are your histograms, these graphs here. There are different types of histogram charts here, or graphs. Let me rather say graphs, right? So when they say it's set of rectangles, they're referring to this shape here. You see this is a rectangle here. Yeah. So they're referring to this shape. I'd rather say bar. Don't like ten. I prefer bars. Apparently, this is the best form of collecting plus register. So I will next time come with my own paper. So the university prefers this method. It's the only one that you can use to really trace who's coming or not, unlike the one for signing for each other. All right. So it represents graphically the frequencies of the observed values. The frequencies. So it is used to represent the frequencies. Okay? The graphic, okay. Histogram is used to do what? Histogram is used to represent, to graphically represent the frequencies of observed values. So I want to make my life easy. For now, just on. I'm going to pray about the most. If we have to get a more proper field. In fact, that field that will come, the field we're going to come, that one that comes separately from part of you, the ones that are going to be covered, listen to me carefully. That is what it said. Then the one that I will be asking in the test 1, the upcoming test 1 is these types of explanations that I want. Why do we use histograms? What is this intended to do? To understand? That's why. Because it will help you to understand why we need the histogram. What does it represent? And so on and so on. Because I've noticed that the book goes to the point that for every formula it gives us, it tries to define and explain why we're doing it. So that's how I'm going to approach my test. And once we are done with this chapter, we've done the what you call it, the exercise problems. Immediately after that, we must know that the test question one is already read. Ne? Test question one is read. And then what could give me an issue is, let me think. Okay, I might need a little bit of theory from the other chapter, but if I am to do enough calculations here, then I won't. The theory from the other chapter, I'm not going to do it. It's fine now. It's for exam. So now, and the exam, if you pass the calculations, you've passed the exam. Yeah? Then the theory will be just to, because we're doing a module that has a lot of theory, we just add it there and there to give it some weight. I'm not going to adopt anyone's question paper. I was advised to do that, but I want to adopt what I've taught. Simple as that. So now, another type of graphic representation is the relative frequency distribution. Ne? Relative in this sense means the proportion or fraction of the total. Relative frequency is calculated by dividing the frequency for each data value. In this case, number of non-confirming by the total, which is the sum of the frequencies. These calculations are shown in the third column of table 5.3. So we're going to move to that table. Before I draw the histogram here, I'll simply start here. So now, the first thing first you do, guys, yeah? I couldn't erase this because, like, yeah, I was preparing the entire time. You see, the big problem in my department is that they'll give you a module and still expect you to be busy at work, coming every day, and you don't get a chance to prepare. You can only prepare at your house. So now we have our 1, 2, 3, 4, 5, né? As you can see, and then we have those frequencies from top to bottom. Né? It's common that they are sorted. It's common that they are sorted from the highest to the lowest. Né? So even if you don't sort by this, you sort by frequency from high to low. Ne? So in this case, it was a coincidence that from our least non-conforming value, they kind of corresponded. They started from top to bottom. But usually you must sort it by yourself, ne? From top to bottom. And you sort them by frequency. Ne? This might be as an approach. However, in this case, I might consider these low-level questions. So I wouldn't say to you, I don't set this in a test because of already the semester is gone. In a normal circumstance, I would go to grouped data and focus on grouped data. But here, yeah, it's up for consideration. Okay, so first and first, after you sorted them from on descending order, you need to do this to add the. You need to add the frequencies. Ne? So obviously we have 0, 1, 2, 3, 4, 5 as our non-conforming data, ne? Or categories. Then we have frequency 15, 20, 18, 5, 3, 1. Then you need to add them all. It's going to be 15 plus 20 plus 8 plus 5 plus 3 plus 1. Then you get 52. That's your 52 there. Then what do you do with this 52? You're going to use it to find the relative frequency. Ne? So 15 divided by 52 is equals to 0.29, okay? And then followed by 20 divided by 52. What is it? Yo. 0.38. All right. All right. Then let's just do the other one. This one, what is it? Wow, guys, I can't hear you. Let me just DIY. Okay, 0.15, right? 0.09, okay? 96, let's say 96. 0.096. 0.58, né? Okay, 0.058. Then 0.019. Okay, then we have that. All right, so when the sum of all, the sum of all must give you a 1. Yeah? So let us attempt to sum them all and see what is it that we're going to get. So I want you to round up here. We want to make this one a 2, want to make this one a 1. Yeah? We round it up so that we maintain the same decimal values. Then have that notion of keeping the same decimal values. So 0.29 plus 0.38 plus 0.15 plus 0.01 plus 0.05 5, I think that's 6 plus 0.02. Okay, I'm getting a 0.91, but that obviously when you round it up it's going to be a 1. So let me confirm. Yeah, I don't know why I did not get this. Let me see. 0.293815 0.01, that's a 1. Yeah, 0.6, 0.2. Okay, even though I'm not, the answers are not make sure, but yeah, the answer is supposed to be 1. That is 100%, right? Then now we're going to do the cumulative frequency for that. Yeah? So they're going to accumulate. Yeah? This is going to accumulate. So the cumulative frequency, is this, guys. Again, it comes here. You do the accumulation ion, guys. That is your 15. 15 plus 20, 35, ne? All right. Plus 8, 40. Plus 5, plus 3, and then plus 1, that is 52. Obviously, yeah, when I write with the digital pen, it tends to be a problem to get the lines properly, but it's fine. You can almost see, or let me just readjust it here. 52, this one 51. You still remember? Okay. 35, 43, 48. Right. Now we redo this. The cumulative frequency now must go all the way to 1. Ne? So then it's going to be 0.29 add to 0.38. That is 0.67. 0.67 plus 0.15. 0.82 plus 0.01. Agree that it's 1. And then that is your 0.83, 0.83, then plus 0.06, then that is your 0.89. Where's the mistake? 0.10. What do you mean? Wait. All right. Okay. Wait. We are saying 50. We are saying 5 over 52 is 0.096. Yes. So now, I said we must change it to. I did mention that. We just change it. This one, it's 1, right? No. Oh yeah. I'm crazy. Yeah, no, I see. Give maths, guys, not me. It's maths, right? So now let's just run it up, even all these ones. 6, and then this one is 2. No? Yeah, the man is right. 2. Right. Then when you sum them up, 0.929 plus 0.38 plus 0.15 plus 0.1 plus 0.06 plus 0.02. And that's a y. Yeah. Ikawa. So now we're going to go back until here. We are right until there. So now 0.82 plus 0.1. 0.1. And you're getting 0.92. 0.92 plus 0.06. That's 0.98. Do you see that? 0.02 is going to give you a 1. And then you can have frequency diagrams for all this data. Ne? For all of them, you can draw a frequency diagram for them. So for instance, I'll do for this one, ne? And I'll do for this one. You'll practice the rest by yourself. So now, yes. When you get to problems, that's when I get you to ask I'll tell you, because I haven't yet holding there myself. I think need quality control, uh, car, I think 2012, you know, so that was the last time they did. So you can imagine. So obviously I ask questions. I don't ask you that you know. Ne? my 9 months working experience as a lecturer. Because I've worked 9 years as a lab technician. Yeah? So most of my work revolved around quality control. So I did a lot of quality control calculations, but on Excel. That's why I gave you a link uh, that was going directly to my previous work. So now, if I am to give you this, first and first I will say find the frequency, okay, from the gate. And then maybe that is 5 marks. Then next step I'll say find the relative frequency, find that, find that. I realize when I do the approach, students have come up with that. So I don't know what we're doing. Whereby just find the frequency and make a plan with them. No, I no longer do that. I ask you what I want. So, and also you answer based on the question. Ne? At times, I'm the one who's setting the question. I might ask you like in the form of, let's say for instance, I don't ask cumulative frequency. I can do that. I can still continue with what is to relative. And I say, okay, after frequency, I want you to give me cumulative frequency. The order at which I'm asking them, it's the order that you must answer. Not, you don't follow this order, you follow what you ask. So you be A, do the frequency, B, do the cumulative frequency. It makes logic sense to ask it like that. And then after that, do the relative frequency and do the cumulative frequency. All right. So now, all right. So we're going to draw the graph for this and for this. These are the graphs that we're going to draw. Right. So now, for this one, you can see it goes out all the way to 20. So you will say, you come up with the scale now. Let me bring a ruler. Where's my ruler now? Hey guys, my ruler is malfunctioning. My ruler doesn't want to come. It's fine. I'll leave without it. Okay. So what is going to happen is we say 0, 5, 10, 15. This is ugly. All right, guys. So now 0. What is the frequency of 0? What is the frequency of 0 here? 15. All right. Then you actually, for frequency, you draw it. You draw this frequency slightly uniquely, ne? Let me show you quickly, guys. 15. Then you go down, ne? Guys, that's your 0 at the center there. That's your 0. Then this one is 20. Then you go down. That's your 1. Then 2 is 8. 8 is somewhere here. Then 5. Guys, then 3. That is your 4. And then your 5. Your 5. You see that? And then you can do for, okay, I said I will do also for this one. So this one goes all the way to 100. Ne? This one goes all the way to 100. So you're going to have it as this is in a percentage form, by the way. So you can simply say 10, 20. Yeah, here we are suffering, ne? They must give us proper tables. What is this? Don't say I'm spoiled. Ten, 20, 30, 40, 50, 60. All right, I'd rather use 20. 20, guys, 40, 60, 80, and 100. Guys, come on, guys. Then we have your 3. 3 is around about here. And you have around about 67 somewhere here. So I'll give you a graph paper in a test again. And then we have a 0.82. Then we have a 92 somewhere here. And 100. So this one is for what? Relative. And then this one is for frequency. You can do the rest again. You will be able to do the rest. All right. Let's move right along. Right along. So now we are going to introduce the grouped data now. Ne? The grouped data. So the construction of frequency distribution for group data is more complicated because there is usually a larger number of categories. Ne? A larger number of categories. What are your categories? The categories are this 1, 2, 3, 4. You see the 0 it's a category and it has frequencies. How many zeros are appearing? There are 15 in this case. Again, so same apply with group data. It is stated that it has a larger number of categories. Ne? So how many categories did we have initially? 5. It's actually 6, 0 until 5. Yeah. So now on this case, we have a usually larger number of categories. How do you do how do you see that you need to do uh, the frequency distribution of group data? How you treat it as a group data is when you see that the number of categories are larger than normal. Okay? So for an example problem using continuous variable illustration illustrates the concept. Ne? Okay? So I think, am I supposed to start here or what? So now in this in this table we have up to 43 categories. See that? Up to 43 categories. So that shows you from 5 to 43, from 6 to 43. That's quite a good, a big number there. Ne? So I want to see from where do I go where. Uh, I might have mixed my screenshots, but nevertheless, let me just rather read here. Number one, collect and construct the tally sheet. Ne? The data collected on the weights of 110 steel shafts are shown in table 5.4. This is table 5.4 here. And then the first step is to make a tally of the values as shown in table 5.4, 5.5. So this is the table of tallies. Ne? I would like to, I'll never give you 110. Yeah, then now it's excellent. On Excel, can give you 1,000. Because you can do report on Excel from highest and lowest to when you start to work around minus 10. But not here. Here we can, maximum of 20. And lower there when you see all the tedious, I'll still reduce it to maybe 10 or maybe 10. But yeah, I will never go beyond that. I'll never go beyond that. 110 samples is just a lot. But it has to be doable. If I do 20, it's because of it's doable. If I do 10, it's because of it's doable. But I will drastically reduce them. Ne? So now, then if it happens that you give me 110, I'll give you this table that comes after here. The tally sheet weight. Ne? I'll give it to you. So that because this thing will require you to say, okay, what is the lowest number here? You look, and then you'll find that is 2.531. Then you write it there, all the way to the last number, which is 2.575 after the 110th time. In a 1 hour period, we won't win. That's a fact. Oh, actual 1 hour test, we won't win. That's a fact. However, I'll either give you this or keep it short. I think we're still exploring our options. Okay. Then okay, I must go here. Let me finish reading here. So now, in order to be more efficient, the weights are coded from 2.5 gram. Ne? This is a nice approach. This is a nice test approach. So you see, they say every number is actually from 2.5 kilogram. Ne? So then when they are removing, please, I don't want anyone to be confused by this simple thing. This is like 2.531. You see that? These are coded from the 2.500 gram. Ne? They got it from there. So basically, when you see the 31, it's more like it's 2.531. Just like they have it here. Now you see. Yes. Okay. So because they're saying for efficiency purposes. So I can also give you these values as whole numbers actually. Instead of saying 2 point, I can just give it to you 31 and it will work with your these whole numbers. Instead of the commas and the commas, they tend to confuse. But I'll explore that. And the aim, I have no desire to have a lot of dead bodies. I don't have that desire. So I'll try to be as straight as forward as possible. Okay? Then, which is a technique used to simplify the data. Therefore, a weight with a value of 31 is equivalent to, you see that? Now they are explaining it on the book now. They say the weight with value of 231 is equivalent to that. So analysis of table 5.5 shows that more information is conveyed to the analyst than from the data of the table 5.4. What it means is it kind of makes more sense here than this data here. This is just too complicated. It requires Excel. With Excel, you will enjoy it. But unfortunately, we're not having that luxury of Excel in a test. Okay. However, the general picture is somewhat, it's still blurry. In this problem, there are 45 categories which are too many and must be reduced into group cells, ne? Grouping cells. A cell grouping within a specified boundary of observed values along the horizontal axis of the histogram. So now I want to skip. I don't want to read everything. If you want more clarity, you go read it by yourself. Ne? Okay. So the number of observation can be required. Trial and error determine the optimum number of cells. Right. Use 5 to 9 cells when the number. Okay, that part. No. Let's rather go straight to what is required from us. Determine the range. If we're doing the histogram, let's do first determine the range. And the book is saying that you must determine the range as first thing first. So when determining the range, you know the range is the highest minus the lowest. Thanks. So now you come there. Everyone can see which one which number behind with 8 given taken. And everyone can see which one is below. We move up. Like about you guys, you are pure engineers. So there are things that I must assume that as people with a background of mathematics, you should be knowing. So now, which means R equals to 2.531 minus 2, no, 75 minus 2.531. How we are 1? What's the value? Okay, that's my R. Right. Move. You go into it. Secondly, we're going to look for area number 2. Determine the cell interval. The cell interval. Let me explain something on histogram. This is here, guys. Here, it's your lower boundary, ne? LB, lower boundary, and then upper boundary, midpoint. Then lower boundary and upper boundary, and then the midpoint. There. So now, interval is the distance between one midpoint and another midpoint. There's a distance between one midpoint to another midpoint. So the gap between these two. And it's fixed. It's fixed. Yeah? It's fixed. So we're going to go back to our explanation now. As you can see, they've just zoomed it out like this. They've just zoomed it out like this. They are showing you what? Midpoint, say 2. And then they are looking for the gap in between them. You see there? The gap in between them. The cell interval is the distance between adjacent cell midpoints. Ne? Adjacent cell midpoints. I want to why is a problem. Now, for no explain and to Mara explain that you feel like it. That's so all right. So, then, whenever possible, an odd interval, ne? An odd interval is recommended. I won't mention the numbers there. An odd interval is recommended. Guys, another rule that you must write down. Whenever we're looking for interval, we don't run out. Then we just take the number of what? Of decimal place 1. If it's 0.0179, we don't round up. We take the decimal that we're looking for. As the now. Without rounding up or rounding down. That's the rule number 1. So now we recommend that the interval becomes a what? An odd number. Okay? An odd number. So that our midpoints can be in the center. That's what they explain. Something of the clinch. Yeah. They say so that the midpoint values will be the same number of decimal places as the data values. Yeah? So that's why it's a thingy. But in simple terms, you cannot have 0 point. If it's the data was 0.67, you need to and you don't round up. I was always rounding up and from Excel, and I was making mistakes. Yeah, for 9 years. I only discovered now. But I was not teaching the staff. I was a lab technician, so my job was perfectly fine. Yes. I can see that we haven't moved an inch of the chapter. We haven't moved an inch of the chapter. So it simply means that we will be carrying on from this chapter tomorrow, and we'll be closing it. Then Monday, maybe on Monday, because me I don't like this holiday, the class distribution of values. They give me a class on Monday, which is online. Then I'm a Friday. That sucks, honestly. But yeah. The university did a good job because I no longer have a Puza weekend or a Friday. From Friday, I prepare for a class here on Monday. We're not done, guys. We'll finish at 10. Hi, guys. Hey. So now, this is a formula. This is a formula that we're going to use. They have, the simplest technique is to use the Stargis rule, ne? Which is the formula. Ne? Or the I'll tell you now. And we'll speak to the formula and apply the rules. Okay. So they say the formula is that then I is equals to R, which not R like that, which is 0.044 over 1 plus 3.322 log of what? N, which is your 110. Okay? Then the value that you're going to get, what is the value that you're getting? Are we all getting 0.0057? We're getting there. So now, but if you look at that, if you look at the number of decimal places that we have there, Yebo. 110 is the sum of all the values that are here. Where's that table? All of them here. Yes. I am most likely to tell you that. Don't be complete. I will tell you that. Unlike your I'm getting time. Yes, you won't fail, but time. You know that I know very well. I do not capitalize on them. But we have next one. I won't cause you more anxiety than you have. Hmm? The sum, yeah. Not the sum. No, not the sum. Not the sum. You count them. Of number of observations. Yeah, the right term. Yeah. Yes, guys. So now you'll notice one thing. How many decimal values do we have? 3 again. The answer is giving us 4. Ne? So they will say to you there, the closest odd interval for the data is 0.005. We do not round up. You see that? We do not round up. So that 7, that's why I have highlighted it like that. That 7 falls off. That 7 falls off. So then our I is equals to 0.005. If you can apply this rule, you're done. No trial and errors. I don't like the trial and error approach. So now we need to find, then determine the age, the number of cells. Yeah? We go rectangular. How many are they supposed to be? Not how many parts. How many parts are they supposed to be? Ne? So from here, determine the number of parts, which is age. Ne? Equals to Is it R over I? R over I, which is 0.044 over 0.05. What's our value? It's 8.8. But remember, this is are these bars. These bars here. These bars here. You cannot have them as a comma. You need to round up. Therefore, we have 9 bars. Ne? You must round up. You will have 9 bars. All right? So, next up, determine the midpoints. Determine the midpoint there. So now we have this formula. They are saying this for the first time. Do not round up your answer here for the first time. Don't round up anywhere. Don't round up. They are concerned about the midpoint. Now said do not round up. And be careful. You will find a number that is having more decimal views on the calculator. And then you will feel a need to say, plus whatever. You go back and rewrite it again into the exact decimal numbers. Then that's when you can use it. So don't just go. Yes. Can you start this? Now, guys, come on, I'm pick up this digital pen. Even on the board, I write badly. Something is a crash. A 0, 0, ne? All right. Forgive my handwriting. Maybe you must just give me a page to do because I write like a doctor. So now, look at the formula there. Let me show you something about midpoints. Ne? Before we look for these midpoints, look at this. Guys, I'm going to make a straight line here. What's your lowest value? It's 2.531. The second value, okay, there is a second value. I'd rather say I don't know it. Then the midpoint and my third value there, right? So that's my x2, x3. Ne? I don't want to write a lot of values. I'd rather say x2, x3. Then midpoint. My first midpoint. Ne? My first midpoint. What do we know about the interval? We know that the interval is from one midpoint to another again. Let's say 2, MP2. That's your I. Mara, we are here on XI, which is the first or the lowest value. Ne? We are there. So, how can I get this value? By looking at that. You can see, Hori, if the distance from here to there is actually the similar distance from here to there. Okay. Therefore, so I is also here. I is also there. Then we derive a formula and say, if I want to get to midpoint, the midpoint will be half of the interval plus the value that I'm at there. ne? Then you're gonna get this following formula. Your lowest value, let me just confirm the formula. It's got xi, xl in fact. Your lowest value plus half of the interval. Half of the interval. Because we understand that the interval, it's also here. The half of it is going to lead us here plus that value there. So that's our midpoint number 1. Midpoint number 1 equals to that. So now, when you look for the midpoints now, so midpoint number 1 is going to be I need to erase stuff here. If I don't erase, it gets confusing. But the nice thing is that it's being recorded so you'll know what came before here. I can? Yeah. And that's why I'm a content creator. I'm not just a typical lecturer. I'm also a full-time content creator. But not a influencer. Not an influencer. I don't influence anything. I influence cause only. Yeah? And that's why I don't have a lot of subscribers. Because of, I don't wear bikinis. I don't even show face on my videos. So 0.05, Hyman, why I always cut the numbers? 0.005 over 2. How much do you get there? 2.533. You're getting it as a 334, isn't it? 335. Okay. So, listen guys. You're getting it as a 335. And then I said to you, because you know that, we know that they said do not round up, okay? Do not round up. And we still want to stick to our values. So you then, that part, it must go away. Ne? But I didn't teach the next part. The next part goes like this. The next part goes like this. So, if this one is comma 533, this is how it's gonna look like. Again, we've explained we are dumping the 5. But some of us, our calculators have the memory. We can just say plus. So, but I want to explain what are we plusing with before we plus. So now, what are we saying about the interval? We're saying the distance between what? Midpoints. Okay? Therefore, if you add your interval here, are you not going to land to your second midpoint? You're going to land there. So now, if you add I here, in every value that you're getting, you're going to land to the next midpoint, next midpoint, next midpoint until. But now, our calculator is having a 4 here, a 5 here. We do not need that 5. Therefore, you don't say plus. No, you retype it again to avoid a mistake. Understand? So you will type it again on your calculator. Then you would say 2.533 ne? Plus your 0.05 ne? Then you are now getting the second midpoint ne? So let's go back here. Let's come here. Your second midpoint is going to be 2.538. Do you see that? If you hit the equal sign, if you hit plus one more time, 0.005, then equals to, you're going to get 2.543. Now we no longer add, we just say equals to. It's going to give you 2.548. Ne? And then you follow that pattern. 2.548, 2.5, I think it's going to be 553. 553, 2.558, 2.563, ne? 2.568, ne? Then the last one is 2.573. Then was gonna go to 7.8. Before you go to 7.8, you come back and look at your highest level. What is your highest level? 2.57. So now, whatever that is happening, 2.57, let's say 3, and then 2.575. This is your midpoint for this one again at the end there. Then you can almost simply determine that if 2.570, so this is our almost, I'm making an assumption now so that for argument's sake, so between 2570 and 2575, this midpoint is this value. Then it kind of tells you when to stop, or you count how many they are. Remember the what is it? The number of mass we were calculating, the value of H. This is where it comes in 9. So you count the midpoints 1, 2, 3, 4, 5, 6 until 9. And also you can verify them by saying that, okay, our last midpoint is not greater than our biggest number. It's in between the center. But to know that center, we need to now formulate what is called cell boundaries. Yeah? It is more like your text bracket. Most of you don't understand but it's hard. So it's not like when you're doing things such as the text bracket. They'll say, when you end this much between this and that, then you are texting you this much. Yeah? So it's commonly used. The guys who are doing maths lit at school, they use this a lot for calculations for text. Okay? Then now there's another thing that you need to appreciate. There are values that I'm going to derive a formula. Ne? I want to derive a formula. I want you to, guys, I'm just going to do the first rule only. You have to finish up the rest of the rules. Tomorrow drawing the graph. Okay? So when I only do the first row, I know. I know. So I'm gonna do the first row. How did I do the first row? Okay. Now we're doing the low boundary, né? The low boundary. So now we have this 531 plus your interval, né? So meaning your XL, listen carefully guys, your XL plus interval, it gives you your lower boundary, né? The formula is not anywhere in the book, so it gives you the lower bound. So which means that if I am to 2.531 plus 0.005, that value you are getting here, the 2536, it's actually your second lower boundary, né? Okay. All right, hold on. We have 2.531 plus interval. I am saying to you, the value that you are getting, you write it here as a 2.536. Ne? It's more like, because here we have a boundary. We have a boundary between here, which is 2.531 and a certain number that is not yet visible. We will find that value next. So now, low boundary for I2. This is how you are getting it. So you're always going to add from here. You're going to add the interval, and the values that you are going to get are for your lower cell boundaries. Then now we want to close it up here by getting the upper boundary now. Ne? To get the upper boundary, you're going to say midpoint, ne? MPI plus half of your interval will give you the upper boundary. Ne? So now that is going to be, what is your midpoint? The first one is 33, ne? 2.533. 2.533 plus 0.005 over 2. Then that value that you are getting, it's going to be here. 2.535. You see that it's not 36. So now you're going to look for values between this. Ne? Now you're going to look for values between this. Where? From this. So between this and that, which is 2.531 and 2.535. Instead of saying 6, you do not count 6 as part of that cell boundary. So now, under that, you are having 1, 2, 3, 4, 5, 6. You are having 6 values. Then your frequency becomes 6. Your frequency becomes 6. Your task now is to find the second upper boundary all the way until 9. Then you populate the frequencies there. You populate the frequencies there. So which means that tonight I'm also going to tonight. So that is the and possibly if I'm going to make it and solve the problems. So tomorrow when we meet at 10 for 2 hours, we're continuing. My aim is to get to the point whereby we are doing the problems. So that I can know to what extent can I set both the test and the exam. Yes. Okay. All right. Somebody wants me to repeat the frequencies, yes. Okay. All right, guys. Guys, listen. The six. If you were to say, look at your boundaries, guys. Look at your boundaries. It's between 31. Let's just look at 31. Look at this value. 31 and 35. Understand? So if it was in a normal circumstance, you were gonna be forced to look for that here. The values start up between. How many values are between 31 and 35? So you're going to look for 31, 32, 33, 34, all the way. Ne? However, because if we have this table, that's your 31 there, and that's your 35 here. Then you look under their tallies. How many tallies number here do you have? We have 6. We have let me redraw the tallies. How many 2531 we have? We have 1. The 32 we have 2. The 33 we have 1. The 34 we have 2. Then you add. This is 3. This is 3. It gives us 6. Then the frequency is 6. Guys, I know that